Assalamualaikum warahmatullahi wabarakatuh. We are from the group 1 of Biochemistry subjects wants to explanation about carbohydrate. Before I start it, let me introduce our member. They are Alda Maiydina Putri, Delfi Ardya Pramesti, Lina Lofita, and Salsabila Febrianti. I would like to tell you a table of content. 1 is definition and classification of carbohydrate. 2. Carbohydrate digestion. 3. Carbohydrate metabolism. 4. Carbohydrate discussion. And 5. Carbohydrate relationship with nursing. Let's begin with the 1. Definition and classification of carbohydrates. Carbohydrates are polyhydroxy compounds of aldehyde or polyhydroxysos. Therefore, carbohydrates have 2 important functional groups. 1. Hydroxyl cluster. 2. Keton or aldehyde cluster. Carbohydrate classification. 1. Monosaccharides, the simplest carbohydrates and cannot be hydrolyzed further. 2. Disaccharides, carbohydrates containing 2 units of monosaccharides. 3. Oligosaccharides, carbohydrates that if hydrolyzed produce 3 until 8 units of monosaccharides. 4. Polysaccharides, carbohydrates that if hydrolyzed produce many units of monosaccharides. What is monosaccharides? The simplest unit of carbohydrates with the formula CnH2nON where N equals 3, HC3H6O3, triosa C4H8O4, tetrosa, and so on. Types of monosaccharides. A. Aldosa, monosaccharides containing aldehyde cluster. Example, glyceraldehyde. Cyclical structure of monosaccharides. Aldehydes and keton can react with alcohol forming hemiacetal or hemiacetal. Hemiacetal or cyclic hemiacetal is formed if keton or aldehyde and alcohol groups are present in one molecule. Example, for hydroxypentanol.
Monosaccharides have carbonyl cluster and hydroxyl group in each molecule. Therefore, monosaccharides and from hemiacetal or cycle hemiacetal. Example, glucose. Monosaccharides physical properties. 1. Colorless crystalline solid. 2. Dissolved in water. 3. Cyclically soluble in alcohol. 4. Insoluble in either chloroform and benzene. 5. It tastes sweet among the monosaccharides with the sweetest fructose. Glycosidic bond, such as acetal or ketal, are called glycosides, and the bonding of the anomeric carbon to the OR group is called a glycosidic bond. Glycosides are named after their monosaccharides replacing the A suffix with id. For example, glucose and manosa. What is disaccharides? Disaccharides are carbohydrates consisting of 2 monosaccharides units. 2 monosaccharides are linked by glycosidic bonds between the C anomeric of 1 monosaccharide unit and the OH group from the other monosaccharide unit. Some of the most common disaccharides are maltose, calbiose, lactose, sucrose.
In maltose, the glycosidic bond occurs at the C1 atom of one glucose with the C4 atom of another glucose. So the bond is called a 1,4 glycosidic bond. The anomeric carbon in the glucose unit to the right of maltose is in the form hemiacetal. So it will be in equilibrium with the open structure. Therefore, maltose may react plus with to tolerance. Lactose is the main sugar in breast milk and cow's milk for the egg version lactose. The anomeric carbon in the galactose unit has a configuration at C-1 and binds to the min-OH group at C-4 glucose units. Galactosemia is a disease because it doesn't have an enzyme that can isomerize galactose into glucose, so that it cannot digest milk. Sucrose is known as sugar. found in photosynthetic plants which function as an energy source. For example, in sugarcane and sugar beet. In sucrose, the two anomeric carbons in both monosaccharide units are involved in glycosidic bonding. The glycosidic bond occurs between cymin 1 in the glucose unit and cymin 2 in the fructose unit, so it doesn't have a hemiacetal group. What is polysaccharides? Carbohydrates that contain many monosaccharides and have a large molecular weight. Polysaccharides hydrolysis completely will produce one type of monosaccharide. Monosaccharide units can be linked linearly or can be branched. Types of polysaccharides is starch and glycogen.
Polysaccharides stored in plants is a major component of grains, potatoes, corn, and rice. Compounds of D-glucose units lack a bond 1 for a glycosidic bonds. The branches are connected by 1,6 a glycosidic bond. Carbohydrates store energy stored in animals. Mr. Glycogen turned to starch, composed of more than 100,000 glucose units. The structure is branched via 1, 4, and 1 glycosidic bonds, insoluble in water, soluble in nonpolar organic solvent, other chloroform, hexane.
Other polysaccharides. 1. Cellulose, a nitrogen-containing polymer forming the crustacean cell and outer skeleton of insect. 2. Cytine, a polysaccharide that contains nitrogen from the cell of crustacean and the exoskeleton of insect. 3. Pectin, a linear polymer of digalacturonic via 1,4 a glycosidic bond. There are virus and bunina.
Carbohydrate digestion. The process of digestion of carbohydrates. The oral cavity. The process of digestion of carbohydrates starts from the mouth cavity. Carbohydrates contain fats in the oral cavity, so that is mixed with saliva. Saliva contains the enzymes that work to break down carbohydrates into glucose, but if communication is made slower by amylase, carbohydrates are generally directly converted into maltose. Please be aware that the amylase work optimally and pH of saliva is neutral. Third, on this organ, process of digestion of carbohydrate is obsolete, not happening. The was just passing through easily in a matter of seconds because the channel of the esophagus is very slippery due to the fluid mucus that is produced the wall. Stomach. Carbohydrates directly will shape the stomach to then be processed and mixed with stomach acid. HCl is corrosive. Mixing carbohydrates, stomach acid, and other foods occurs with the help of the movement of contraction of the stomach. This process makes the carbohydrates become more liquid and crash. Liquid carbohydrates are mixed with other foods and then coated with the germ of the Kemenkes. The 12-finger intestine. The process of digestion of carbohydrates is the intestine fingers done chemical using enzymes. Amylopsin or enzyme amylase is produced from the shape of the pancreas. This enzyme breaks down the starch that has not had time to decompose perfectly in the oral cavity to be digested. The small intestine. The process of carbohydrate digestion in the small intestine serves a few vital organs that each have a different role. These organs among others: the jejunum